All right, guys, welcome to another episode of CUDA Education. Today, I just want to continue on our path. So, this video, I'm just covering this little snippet right here. Okay, so this is create the ray tracing pipeline. We just finished dealing with the shader groups, right? So set up ray tracing shader groups, and we already know the spare V files and what they do. We know the shaders. We know the this is the raygen, the miss, and then the closest hit, right? So raygen is we are generating rays into the scene. Miss, what happens when we miss all objects in the scene, and what do we show? And then closest hit is for when we hit an object, what do we do? And you know what's the color of the pixel when we hit an object and all of that stuff, right? So this is for the ray tracing basic. The next order of business is create ray tracing pipeline. Now I will warn you, this create ray tracing pipeline, it's a second mention of like this comment, right? So right, so you see a line 586, we have create ray tracing pipeline, but this is more how do I say this? This is more like descriptor set stuff. It's like shell stuff. It's like, you know, putting in the buffers, the buckets, the memory, setting up the memory structure and resource structure of you know what's gonna happen, right? So that's what this piece of it is. Descriptor set stuff. I have many videos on descriptor set and all that, right? So so we have the descriptor set stuff and the layout of the bindings and you know, things of that nature. Then we get into the shader group, which we just, you know, I just talked about, and then we go back to ray tracing pipeline. But now what we're doing in this set of code right here, what we're doing now is we're tying in all of the shader groups information into the pipeline. So we have vk ray tracing pipeline create info, s type vk structure ray tracing pipeline. Stage count is a calculation based on the shader stages, right? So remember, the shader stages is a vector, and then we like push back the different shader shader groups into it. So we have the raygen group, the miss group, and the closest hit group, right? So you notice that we have the pushback here, all of that stuff. You're kind of just pushing stuff into the vector, right? And then we right, so that's stage count and group count. Now in more advanced algorithms, I guess we'll cover the difference between stage count and group count. But for this example, both of them are 3. These values resolve to 3. But you could get more creative with them based on more complex arrangements. I'm not going to get into that right now because I don't know myself. But and then we have the stages here, group here. This is an interesting one. Max pipeline ray recursion depth, right? Max pipeline ray recursion depth, right? This is an interesting. It's an interesting friend of ours. So remember, we're back on the ray tracing pipeline, and we're kind of like piecing together all the shader groups. This max pipeline ray recursion depth. Okay, this value defines how many times a ray can recurse into additional rays, such as when calculating reflections, refractions, or other effects that involve secondary rays being traced from primary rays. Okay, so yeah, basically, I guess it's like a ray spawning into multiple other rays for like shadows reflections, all that good stuff, right? Now I've tried here we have it as 1, right? So it's hard coded to the value of 1. I've tried playing around with this value to see if anything happens with our triangle. Nothing happens. The only thing I will say is that the max value on my hardware, is about 31, right? If I set this value to higher than 31, basically the algorithm crashes. Reason being that between the driver and the GPU that I have, if you start spawning off other arrays, you have to have the memory, you have to have the stack, you have to have the your shaders, all your shaders, your closest hit, your miss, and your regen have to be able to accommodate spawning off more arrays from an initial array, right? Their driver considerations and all that stuff. So basically, their hardware limitations and driver limitations and software limitations and stuff about how many you can recurse off. Again, for me, basically I change this value and nothing changes all the way up to about 30, and then after that it crashes, right? So there's nothing visually that you see change with this guy at all. But I have gone into the other ray tracing examples. So remember, all of these guys are like ray tracing, right? So on a couple of them, so like with ray tracing callable, we don't have a value of like 1. We have a calculation, right? Right, and then like on the ray tracing intersections, we have a calculation. Ray tracing reflections, we have a calculation. Ray tracing shadows, we have a calculation. Now I have tried on these examples. I'm not gonna run the code. I'm not gonna run these for you to see. You guys gotta wait or do it yourself, right? But I've tried playing around with these two to like just changing it to 1 or changing it to 30 or changing it to 25, but like visually I don't see anything change on it. So I don't really know. But it's something I want to keep my eye on because I think this can be really cool. Hopefully an example is created where if you change the max pipeline ray recursion depth, that you might visually see something different. But as of right now, all I know is that if you make it too high, it crashes, and then every other value below the 30, it doesn't really change anything for the examples. Okay, but anyway, let's get back to the task at hand. So we have layout, pipeline layout, ray tracing pipeline CI layout. Is this guy right here? Which is a variable that's like been used elsewhere, right? I don't think I think we've been building on this. So let's see. So right, it was initialized here. And then right, we put it into this bucket here. And then we do our lowercase vk. Anytime we have a lowercase vk, we know that it's serious business. We're actually doing something with the API now, right? It's like serious stuff. So we always do a vk check to just make sure if it crashes that it handled gracefully. But vkCreateRayTracingPipelineKHR. We have our device. We have a bunch of null handles. This is I think it's just one. I mean, yeah, I think it's yeah, I'll figure out what this is. But then we have our ray tracing pipeline CI, which is basically you're just encapsulating all of this information into here so that the function has access to it, right? And we're putting in all our shader groups and everything into it. And then our handle for the pipeline is this guy right here, pipeline. And this is immediately used. This is immediately used. It's immediately used. Like in the command buffer and all that stuff, right? So Yeah, we're gonna go through the whole thing. Where are we? Where are we? Right. So we immediately use it. Yeah. So we immediately use it for a bunch of things, right? But yeah, we do all this work. Our ray tracing pipeline now is in this variable here, and that's pretty much it. So we have our shader groups, and then we finish creating our pipeline. All right. So that's pretty much it for this video. I don't really have anything else to discuss. Right. This guy is just a number of elements in our creating form. We're just dealing with one element right now, so it's just that one. Okay. So we're not gonna we're not gonna. Yeah, so that's pretty much it, guys, for this piece of the code. It's a very important piece of code. Don't let's not trivialize it just because it's a small section. It actually is doing a lot of, the way how Vulkan works is a lot of build up, it's a lot of typing, a lot of setup, and then you basically have this one lowercase vk function that puts it all together and actually does something in the API, right? And that's pretty much it, right? And that's that's it for create ray tracing pipeline. But yeah, this max pipeline ray recursion depth, I'm really curious about it because I really want to see an example where, like, if you change the value of ray recursion pipeline, that it changes something visually in the scene. I really want to see something like that because it would be really interesting to see. I also wanted to see where, like, if it would create a frame rate hit on the application. So if you make the value too high, your application runs slower because you have to keep track of all the other rays that you have spawned and all that stuff, right? But yeah, definitely, guys, Google this and see what it has to say. So of course, guys, I have to say, if you want to join in on this on this whole thread that we're doing, tutorial number 1 and tutorial number 13. Tutorial number 1 is installing the Vulkan SDK, and tutorial number 13 is installing all the examples. You get all of these examples here. It assumes you have a Windows-based machine with a Vulkan-capable GPU. If you want to be able to run the ray tracing stuff, you have to make sure that your GPU is ray tracing capable. For NVIDIA, it's RTX and above. I don't know about AMD or Intel. But yes, this is all of our, I plan on going through these examples and just learning Vulkan along the way. So I will continue on this thread. Definitely get tutorial number 1 and tutorial number 13. Like and subscribe. Get your friends to also follow this and learn different things. So, like, if you have a bunch of your friends, one can focus on one topic and another can focus on another topic, and then you guys can share notes, and eventually you'll make your way to creating really cool computer graphics applications yourself, right? It's a process. Nothing happens overnight, but you do things one day at a time, and eventually you make a lot of progress. That's about it, guys. Thanks for watching.